My title is Estimating Vapor Pressures of Pheromone Compounds Using Gas Chromatographic Retention. Accurate determination of vapor pressures of organic materials is important for predicting samples' environmental impact, but it is difficult to directly measure accurately because it is costly and lengthy process. In this case, we can rely on indirect methods, but the uses of standard data sets is crucial in this method, and many of previous studies have tried to follow gas liquid chromatographic retention, but our method's difference is we are using multiple standard reference methods. If we follow and rely on only one type of standard, sometime due to difference in standards functional group and samples functional group, we might get different results. So in this case, if we follow, for example, our sampled are ester. So in this case, we are following both alkane and FAME mix as our reference standard, because to find the most value from our data, and to uh, examine that if we get accurate result. So, in instrumentation, we are using GCFID, and we are using RTX1 column, which is a simple boiling point column. It is used because it is the most non-polar column, so interaction with the stationary phase will be minimum according to our sample type. And we are using split mode and constant pressure. Helium is used as carrier gas. Now samples. We are using mainly pheromone samples of Asian corn borer. Uh, among the samples, one of them is commercially available in market, and the rest of the samples have been artificially synthesized. Since the analogs of this pheromone sample is completely new compound and we do not know their vapor pressure, so we used this method. So after finding the retention temperatures of the commercial standard and synthesized analogs of this pheromone, we have compared it with an alkane retention time and FAMES, so that we can at least get accurate retention times. So in the first plot, I am showing the retention time and with the temperature trends, and it can be observed that both 6Z and 10 are showing almost similar result with our commercial sample 4Z, and but the sample 8Z is showing some anomalous trend. This reason might be it has a different functional group, or due to molecular weight, or it might be completely different sample. Then we used Bantoff equation and curve plotted them, and from this we have received the approximate enthalpy of vaporization, but this is not our complete work. We will plot and compare the retention factor of unknown samples with standard data sets and determine vapor pressures approximately. And we have more analogs. As you can see that we could not complete calculation of all the samples, so we have to do it. I would like to thank NSF for funding our research and all of our collaborators.